Thank you for having me. Good morning, everybody. I am excited to be here. I've been working with Neo4j for over 8 years, and this is the most exciting time, despite the circumstances. What's exciting about this is the Neo4j 4.0 release, obviously. And so what I thought I'll do, since all our customers were asking for preview even before it was released, and the excitement was clearly there. So I thought I'll pick out some practical applications of Neo4j4 and talk a little bit about that in a short talk. I won't make up all the time that's been that we overran, but I'll try to make up some of them. So the agenda for today quickly is we'll go through a quick intro, and I introduce 3 features or combinations of features and show you some real use cases for them. So quick introduction, we started GraphAware nearly 7 years ago with the vision that the majority of problems that enterprises, governments, and other organizations are facing can be more effectively solved or solved at all in the first place by using graph-based solutions. So we wanted to help people, first of all, see the light, so to say, and I think, or help Neo4j in that job, and I think that's done. I've been to 4 graph tours already this year, and the rooms are always full. I think we have more than 200 people here listening today, so that's really showing the sign that this market is growing and people are starting to use the technology. Our mission now is to help people succeed with the technologies, right? So they don't the technologies don't become some sort of hype that quickly fades away, but rather a long-term solution to the problems people are facing. So we focus on Neo4j exclusively, pretty much, because we believe that it's the best graph database out there. The interesting thing about graphs is they are challenging, both theoretically for scientists and mathematicians, as well as practically for engineers. And I believe, and I'll show you, that Neo4j is tackling these challenges with quite a good speed and super solid design, high quality engineering as well. So, and I think Neo4j4 is a proof of that. So I'll jump right into it and talk about the first use case here and the first practical application, which is fine-grained security. And what I want to do is mention this in the context of one of the use cases that we come across quite frequently, which is law enforcement and intelligence. It's interesting for a number of reasons. One is that, obviously marketing people hate it because there's not much talking you can do around it, and case studies you can publish. However, the other interesting thing is that data security in this domain is super, super important. And I don't mean important because you get sued for not being GDPR compliant, or because you make your employees angry by accidentally exposing how much money management makes. But I'm talking potentially about a matter of life and death, right? Because imagine what happens to people who are part of a covert operation, for example, and their identities get revealed. So this is very serious. So let's look at an example. Say, for example, you're a junior analyst investigating a crime, and you would like to know whether these 2 individuals on the screen are in any way connected. And by the way, for those of you who are completely new to graph databases, this kind of problem is very hard to solve with traditional technologies, right? So take SQL, for example. You would have to enumerate all the possible ways they could be connected in SQL, and that's very, very hard, almost impossible if you imagine that the potential length of the path is completely unknown. So in Neo4j, what you do is you just run a shortest path algorithm, and you see a response, but oops, as a junior analyst, I was not supposed to see the fact that an officer, potentially undercover, is already investigating these 2 individuals. So what we had to do before Neo4j 4.0 is to apply some security on the queries, right? In fact, before we do that, we do something in the application layer. We filter out things in the application and then ask the database for more. But what can happen, and sometimes does happen, is there is no more shortest paths because we have filtered them all out, and maybe there are some paths that aren't shortest anymore, right? So then the next step is basically saying, okay, we're going to have to start applying security on in the queries themselves. And suddenly, okay, we see other shortest paths that are not secret, and we see that these two people, in fact, were communicating. There's some phone calls between them and some SMS, which could be very interesting for this investigation. But now the problem is every single query will be polluted, so to say, with security logic, right? So we're going to have to deal with complexity and changing rules and regulations and team memberships and errors in code and lack of testing and all the rest of it. So, and this is in Neo4j 3, right? So that's before 4.0. So let's have a look what this looks like in Neo4j 4. I run the very same query, and let's say I'm user 1 with top secret clearance or whatever your organization's security model is based on. So you run this simple shortest path query and you get the actual shortest path. Okay, no rocket science. Now I log in as another user, perhaps the junior analyst that we used before as an example. And with the very same Cypher query, I'm now getting shortest path that the junior analyst is allowed to see, but they're very different paths from the previous result. So the database handles this for you completely. Finally, there's a third user that runs the very same query. And what happens is something interesting. It's somewhere in the middle, right? Where he can see the existence of an officer that's investigating these two individuals, but cannot see anything about that person. And no properties of that node are exposed to the user. This is another way of securing nodes and relationships. And I remember talking to Ivan about this a while ago when we talked about security on top of Neo4j, where in relational databases, it's simple, right? You either show the row or you hide it. In graphs, the fact that some relationships and nodes exist can be valuable, and so it demands separate treatment. And in this case, I think the way Neo4j 4 security is designed is very, very useful, because you can choose to either not show that path at all or to show it without details. So to me, to summarize this bit, Neo4j 4 is worth it just for this feature, just for the security, letting your database handle this security for you completely transparently and quite flexibly. I think it will almost literally save lives, right? It's a feature that's useful not just for this one domain that I talked about, but it's useful for every other use case where not everyone is allowed to see everything. And I think that's pretty much all the use cases out there. Moving on, I want to talk about another feature, which is multiple databases, so the so-called multi-graph. This is, for the first time, Neo4j supports multiple databases, and Ivan talked about this. And one clear and obvious practical application of this is multi-tenancy, where you completely want to separate your tenants' data, but it's so obvious. I'm not going to be talking about this today. Instead, what I'm going to do is mention 3 practical applications of this feature to single tenant applications. And I'll focus a bit on knowledge graph applications. All of these use cases have something in common, which is people had to handle this somehow before Neo4j 4 was released, right? So I'll try to contrast these approaches with what it looks like in Neo4j 4.0. And the first one I'll start with is the fact that in a number of applications, what you would like to do is have multiple logically disconnected graphs, right? Still a single tenant, but disconnected graphs. So here is an example of one of our clients, 7vortex, which enables people to create their own knowledge ecosystems. So in the system, there's probably thousands of small graphs like this, and they currently live in single Neo4j database, right? In Neo4j 4, you have them truly physically separated. The other example, which I want to talk about, is Hume. This is our own product. that's built on top of Neo4j. It's a graph-powered insights engine, and what it does, it takes structured and unstructured data and creates knowledge graph out of them, right? And by the way, if you want to see a live demo of Hume, there's one at 12 noon today. Just go to graphaware.com. The latest blog post has all the information about this. It's part of this whole event. This is what the knowledge graph looks like, right? And some of our users would like to, even though this is a single tenant application, some of our users would like to have disconnected knowledge graphs for different domains in the organization, or for different users. And what that looks like today in Neo4j, or today, that means before Neo4j 4 was released, is that the nodes in the graph have to have some special labels that represent, which knowledge graph they belongs to, which makes the graph unreadable and a bit messy, and it's not what you guys are used to from all these demos, right? All these nice and clean graphs. So let's look at Neo4j 4. I mean, it's quite obvious. You've already seen this. You just create multiple graphs in the same instance or the same cluster, and you basically solve the problem. You don't have to hack around it anymore. Another use case with single tenant applications is where you, and this is actually quite useful for knowledge graphs as well, is where you have multiple graphs with different qualities, right? So graphs are naturally multidimensional. So when you model your data correctly, you can store different quality data in the same database by distinguishing by relationship types and labels and so on. But again, in some cases, it's much cleaner, safer, and more practical to separate the graphs completely. So let me give you an example. This could be, for instance, a beautiful, curated, super clean ontology that your team has worked hard to build, right? And at the same time, there is this data, which is machine generated, thereby inherently somewhat messy, enriched from some online source or something. Could be data from the same domain or even the same data set, but just represented very differently and processed very differently, right? The first one was human curated. This one is just machine generated. So possibly you want to separate those graphs and treat them differently, give different people different kinds of access, and also use the insights that these graphs produce differently. And again, in Neo4j 4.0, you just have a clean and a dirty, and off you go. No hacking needed. Finally, one use case that's quite close to my heart is auditing. We have always offered extensions to Neo4j, most of them open source. And one of them has been this audit module that basically does something like this. I'm not going to go into detail, but here you're looking at a graph where the blue node, right, is the only actual real piece of data. It's a node that we have created. It's an airplane, and we've changed one property. And what this audit module does is it creates a whole audit graph inside the same database, actually, to represent things like transactions. Those are the purple ones. Users that have executed those transactions, that are the yellow, that's the yellow user. And then we have some actions in those transactions as the gray ones, and then we have a green node that's a proxy of the real one. So this worked quite well, right? You have a full audit trail that you can query and everything. But again, because it's in the same graph, it kind of makes it messy, right? You can write queries to avoid it, but it's not pretty. So now Neo4j 4, what that will allow us to do very, very easily is just to have the real graph, in this case, could be called call records or whatever, and then you have a separate audit graph, again, with separate permissions and separate users being able to access it. So with Neo4j 4, multi-graph feature makes all of these 3 use cases I just mentioned, and many more use cases, actually much easier. The one important thing is that you can query, as Ivan showed you, all these graphs, even they completely disconnected and logically separated. You can query them at the same time using Fabric and then merge the results together. So this is a great addition to the Neo4j feature portfolio. The last one I want to talk about a bit is scalability. and I want to talk about scalability in the context of graph-powered machine learning. And this is a practical application of Neo4j 4, but also Neo4j 5 and 6, I believe. It's something a little bit more forward-looking, because for the last 3 or 4 years, we've been relentlessly advocating that graphs will be the underpinning technology of good, modern, practical applications of machine learning. So much that my good friend and colleague Alessandro is writing a book about this. I think about 8 chapters are actually finished and ready to be previewed if you want to sign up for the early access program on the Manning website. Alessandro is Italian, so that means the book is very, very big. So it'll take you some time to read through it, but I encourage you to do that. However, graphs and machine learning together are not a novel concept. This book that you see from 1997, it's a classic. It's a Mitchell's machine learning textbook, which I used when I was studying computer science. And this is from 97, and you see there's a graph right on the cover, but there's also lots and lots of graphs inside this book. So this is no news that these two technologies or concepts are a very good fit. And I want to talk a bit about why that's the case. So I'm just going to use this Hume architecture image, where parts of the architecture are centered around natural language processing, machine learning, and enrichment. And I want to talk about specifically machine learning and how that fits into how graphs fit into that machine learning pipeline. And there's sort of 4 steps I want to mention. First of all, right, graphs allow you to store data from multiple different siloed data sources, oftentimes very heterogeneous, in a single graph, single source of truth, right? That serves as context and data source and context for these machine learning tasks. So bringing data into the same place, it's already very valuable, and graph is the best place for it. Secondly, the machine learning itself can use and typically uses a lot of theoretical graph algorithms. Take, for example, random walks, shortest paths, depth and breadth first searching, but there's the newer ones like Neo4j. There's things like PageRank, which we've used, and one of my team members will post a link to that article. We use it to extract keywords from free text in a completely unsupervised way. We call that text rank, and that's something that performs very, very well. Behind the scenes, it's just PageRank. So all these algorithms are very useful for machine learning, and again, a lot of them are actually built into Neo4j. Another important aspect here about graphs in this context is that one can extract features from the graph itself to perform the learning on, right? So these features would be typically related to the connectivity of nodes, such as the degree, the betweenness centrality, and things like this. And they can be used in the traditional machine learning approaches together with the traditional features of the objects or nodes themselves to give us a richer feature set than usual. So when we finish our machine learning process, oftentimes the model that we end up with is actually a graph. Think about Markov chains, decision trees, clusters and similarities. And again, because they are graphs, the best place for them to the best place to store them is actually Neo4j itself. Finally, at the very end of this pipeline, we need to actually use this data for some business value. We need to serve some results to end users or to other applications. And again, there's no better place to do that from than a real-time graph database where all this data, all the models, all the pre-computed similarities, and all these things are already stored. And as a bonus, from using Neo4j as this real-time intelligent system, effectively, is explainability, right? Because a lot of the traditional machine learning approaches are very black box based. So when you get an answer, you don't actually know why you got it. Here in this case, you can look inside the graph and see the context and see the models and see the reasons why you're actually getting the answers you're getting. And that, I think, will be very important going forward because of all sorts of ethical issues and so on. Now, as a lot of you will appreciate, machine learning can be very demanding on computational resources. And this is why it's here in my talk. This is why the increased scalability of Neo4j 4 that Ivan talked about with logical graph partitioning and the so-called fabric will even further enable and accelerate, we believe, this graph-powered machine learning trend. So this is a space to watch in the coming couple of years, I believe. I hope that I've managed to show you a few Neo4j features and how they can be practically applied in different domains and use cases, from intelligence and law enforcement to more forward-looking graph-powered machine learning. We have been and will be publishing a series of blog posts on both neo4j.com and graphaware.com about Neo4j 4.0. We're also here to help with migrations or any problems or questions that you guys might have about Neo4j 4. So I am looking forward to discussing further. Thank you very much.